Welcome, everyone. Welcome. Good morning. Thanks for being here. I'm James Ward. I work at AWS. What do you do?
I work on the Spring team. Good morning.
Yeah. So today we're gonna, what are we gonna do?
Selfie.
Oh, selfie. We gotta take a selfie. Always, always. Josh, why do you take these selfies?
Always, same reason as always. I'm gonna show them to my kid. I'm gonna say, see, they listen to me. Okay.
I listen to you, buddy.
Take a photo. Yeah.
Okay, what am I doing?
With a selfie. It's not a selfie if I'm in it.
What?
It's gotta be a selfie.
Oh, it's gotta be, okay.
There you go.
Oh, there we go.
That'll give me time to turn on the computer.
Oh yeah, you gotta turn on your computer.
Yeah.
Okay.
So good.
Okay, so what we're gonna do is talk about AI. Have you had enough AI yet this week? Okay, we're gonna make it fun. This is gonna be the fun AI session. So, what a great time to be a Spring and Java developer, or Kotlin, if you like Kotlin. I like Kotlin. And so we're gonna go through just some great ways to build AI applications. There's our information. Oh, let's see, we got yours. Josh and I have a podcast together, Coffee and Software.
Yeah, YouTube channel.
Yeah, YouTube channel. That's what it is. It's like a video podcast. Vodcast, do we still call them those?
Hey, in the back, can you all see this?
Font size? Does it need to be bigger? They say bigger and back. We could tell them to move forward. Josh is writing our slides right now.
Yeah, there you go.
I'm sorry, we're a little behind on creating our slides, so we'll get those created.
Can you, okay, there you go. That wraps. That's a little unfortunate, but it wraps. Okay. There.
Oh, here, wait, add one more URL to this.
Okay.
Bootifulspringai.com. Do you remember how to spell Bootiful? Bootifulspringai.com. Josh and I are working on a book about Spring AI. It's not out yet, but you can go there, get information about it. But that's actually where we want to start is this is like yesterday, I don't know, after a couple drinks, and we're like, hey, let's build an MCP server for our book. Because then if you don't want to read our book, you can just have the AI read it and tell you about it. And so we're like, let's create an MCP server for our book. So we did. So go show them our MCP server that we have set up here. So this is in Claude. Here, you ask it. Okay. So first, click on that little plus button.
So plus button.
And then connectors. So we added, there it is, the Bootiful Spring AI, so it's enabled. So we added our MCP server, and it has a login server. We're going to show you how to build all this stuff in a couple minutes. But now you can just go ask it, tell me about the Bootiful Spring AI book. And that's going to go off and actually call our MCP server. And then we're using this new thing called MCP apps. And you have to allow it. Yep. We're like, yep, sure, you can talk to our MCP server.
And you know why? Because it's an iframe.
That's right. And there we go. That's an MCP app. That came from our MCP book server. So we're going to show you how to build some of this stuff with Spring AI.
And this kind of underscores the point, right? The AI is, we talk about artificial intelligence these days. I think its real value, as we kind of underscored in the keynote yesterday, is in the context of existing business applications and unveiling new and deploying new interfaces,
There's like new action paradigms, new services that our users are going to interact with. Maybe they're going to use Cloud.ai. Maybe they're going to use some other AI system. Maybe we're talking about the world of code assistants. We want to provide integrations into those.
Right.
So yeah, great time to like bring that world to the integration world that we've built so many things on in the Java community.
I think, yeah.
Okay.
So with that established, let's build something. Here's the, there we go. We have some questions we need to answer first and foremost.
Wait, no, what are we building?
Yeah.
Oh, yeah.
Thanks. We're going to build something, as always, to help with the laudable goal of helping adopt everybody's favorite dog, Prancer, about which we've spoken once or twice before, right? And Prancer, who knows Prancer?
Everybody knows.
The best dog, right? He's the best. So this dog is, again, the owner was looking for a new home back in 2021 to find this dog. She described this dog rather hilariously. Okay, I've tried for the last several months to pose this dog for adoption and make him sound palatable. The problem is he's just not. There's not a very big market for neurotic, man-hating, animal-hating, children-hating dogs that look like gremlins. We're going to give this dog a home, okay?
I mean, if AI can do anything, it should be able to find Prancer a home. So let's build that.
Yeah. Go to start.spring.io. We are going to use AI. Spring AI supports integration with a number of different models. When we talk about AI models, obviously this is a good, broad term. Most people are familiar with chat models, but there's also image models, there's transcription models, there's embedding models, there's what else, right?
Yeah, model for everything at this point.
So what are we going to do? What's our model du jour here?
So we need a model provider. In this case, we're going to use Bedrock, one of the options available. Bedrock is an AWS service that provides many different models. There's the Claude models. We can go into the Bedrock UI, and we can go to the model catalog and select from, there's like 250 different models that we can use. We're going to use the Nova models, which are Amazon models, but you could use the Claude models, whatever. So lots of different options for that. Even JetBrains has, which it's under, I think, now the market.
Oh, right.
Place.
Okay,
is that right? Yeah, try in there.
Like, I don't.
Where is it? Somewhere in here is the JetBrains models. So yeah, I mean, there's the models in IntelliJ that do the code completion inline. You can use those. Like, it's crazy. Lots of different models. Okay, so we're going to use that. We've already set up Josh's machine to be authenticated to AWS.
Right.
And so now we can start making model invocations, which is just like, hey, in this case, let's send some text and get a response back from the model.
Right. And so when you use Bedrock, you're talking to a network service that is in turn going to route you to any number of different models behind the scenes.
That's right.
So you have, in Spring AI itself, you have portable service abstractions. You have the choice about which model provider you want. And then again, you have extra indirection and flexibility here for your effort by using Bedrock, right? So first things first, we go to start.spring today. We're going to call this assistant because we're going to assist people with building a new adoption thing, right? And then I guess we need some dependencies here. We need Postgres, but I need also a vector store, don't I?
Yeah, so we're going to be doing a number of different ways to do integrations with our AI. So we're going to use RAG, which uses embeddings. We're going to also do auth, so we're going to need the auth pieces. We're going to do MCP, so we're going to need those. The vector store to store our vectors. And then what are we doing? JDBC. So we got a bunch of different pieces that we're going to all pull together to build this dog adoption service.
So the PG vector, though, is kind of a 2-for-1. I need a Postgres access, and I need a vector store. In this case, Postgres can do double duty. Same network server, same process in a container on my machine, but two different data structures, two different data stores for the price of one. However, logically, they could be two different things. When you build this app yourself, you could choose Chroma, Weaviate, or Neo4j, or MongoDB, or Elastic, or whatever as your vector store.
There's like 20 different options for vector stores in there.
Just forever, right? We've got the web support, got the security support. We need Actuator, obviously. What else do we need? We need the model. So let's talk about Bedrock and Bedrock Converse. What's the difference?
Yeah, so we're adding two different libraries there. Bedrock is going to be for our embeddings, which are going to be used with RAG, and then the Converse one is for our chat client so that we can talk to the model, send it a text message, get text back. So those are our two different libraries we're using there. So, okay, so you got your project all stubbed out, ready to go.
Yep.
And,
Move that over there. There we go.
Oh, yeah. Got to get everything all set up, because we're going to give everybody the code afterwards.
Yep, that will be online, and so you know exactly what not to do. Right? You'll just see our terrible code. You're like, oh, no, I'll pass, thank you. Okay, here, so the font, I've been told it's very hard to see. Can you see that in the back?
How's that looking?
It's okay?
They say, I think thumbs up means good, maybe not larger.
I hope so.
We'll see. Okay, so we're setting up some properties here to be able to connect to our database, which we're going to use to house our dogs. It's like a dog house, right?
Yeah,
in this case.
doghouse.
So so we got our dog house where we're going to house them, and then so that's our database connection to Josh's machine. Dog house is the name of our. Oh, you're starting over with dog house. Okay, so. Back to setting up our properties. We're going to have to set up our database connection. Then we have to set up some different properties for which model that we're going to use on Bedrock. We have to set up some properties for our vector store. And so Josh is going to set all those things up. Did you just starting all over?
Just going to copy and paste the whole thing.
Okay. There we go.
So we want the agent here. Okay.
Yeah, we don't see Josh copy and paste much, but for this, I'll speed this up.
Come back a little bit.
Okay, so we've got some security stuff that we'll get to in a little bit, and then what other configuration was in there? Did you miss?
This.
Oh, chat memory.
Forgot that. Shame.
Man, start over again. So yeah, we'll get there.
Okay. What do we got?
So database setup, security setup. We'll get to MCP setup. Do you want to do that initialize true for now, or because that's for security?
We'll come
virtual threads, why not? Then let's see, we've got our properties for which models we're going to use. There's the chat model, which is going to be the Nova Pro, and then there's the embedding model, which is going to be the, which one are we using, Titan or Cohere? Cohere.
Okay. Yeah, Cohere. Yeah.
Great, and then we have to set up these properties for our embeddings with PG Vector. So is that it? We got our app?
Is that it?
We're done? No, we're not done.
Yeah, the hard part's done.
You just have AI do the rest.
Right,
Yeah.
surely.
Okay.
So, assistant, controller. Oh, okay, here we go, right?
Okay, first thing is let's just establish some dial tone to the model, make sure that all works. So to do this in Spring, we have this chat client. The chat client is our primary way that across all the different models we can interact with the LLM. So we're going to initialize that with the builder, the chat client builder, and then let's have a little REST-like endpoint where we can make the ability to ask a question to the LLM. So when we do that, we're going to send a user question off to the prompt, and then we're going to get the response back from the LLM. So that's kind of our dial tone wrapped in a web request.
Looks good to me so far.
Okay.
Restart. Okay.
Let's give that thing a try.
So I've passed in a
user. Did you need to comment out any security stuff, or you're?
Oh yes, that's the saddest thing you've ever.
Yeah, I know. We're going to add security later. So before we do that, we need to comment out these dependencies so that auto configuration doesn't trip us up and tell us that we need to configure security, which we will configure security, just not yet.
Just not yet. Poor security. It's always the last thing people look at. Okay.
Oh, it starts so fast.
So good.
So good.
Ready? So localhost ask. We should just use the console here, right?
Oh yeah.
Okay. See, I've got to make my font.
Yeah, bigger, bigger. Yep. Keep going.
Okay.
Okay, that's good.
There. Can you see that in the back?
I think they say yes.
Okay. So
let's ask a question.
my name is Josh. Are we just trying to do dial tone?
Yeah.
Okay.
Yeah, just dial tone.
Here we go. That's so sad.
Oh,
security is there
denied.
still.
Security.
Did I miss something? Security.
We got those.
Oh, I got that.
There's that one.
I just heard a whole group of people go.
They're like, do not comment out security. Bad idea, Josh. Okay.
The whole chorus in the front just did that. I'm very conspicuous.
Yeah.
Don't think we didn't notice.
I mean, somebody's tweeting this right now, and they're going to say, like, hey, they turn off security. That's what they do in the Java community.
It's not the message. Okay. Hey, hi, Josh. Nice to meet you. By the way, that was...
Oh, so good. Okay, great. So we're talking to our model. And that's just step one of being able to build our AI adoptions application.
I think we're friends.
Yeah.
Let's just make sure. Should be good.
Oh,
right?
before we do memory, we're switching up the order. We're going to do skills.
Oh, right. And the
system
We
prompt.
also need a system prompt. So, okay, we've got this thing. Let's ask it about dogs. Like, we want to ask it about dogs, right? Do you have any neurotic dogs like Prancer, right? So, okay, it's given us a response, but it's not the response we want because it doesn't know we're trying to adopt a dog. It thinks we have one and we're trying to figure out how to deal with it. And that's just not the case, is it? So, and if you look at this, we actually have, we have a goal here. We're going to help people adopt a dog from our fictitious dog adoption agency called Pooch Palace. We need to focus this model on that mission, and one way we can do that is by giving it a system prompt. And I happen to have a system prompt pre-written, and so we're just going to copy and paste that. We're just going to cat that and then pipe it to the clipboard, and then we'll paste it. Wait a minute.
Of course. You got to dog that file, man.
Okay, yeah.
Yeah, we're talking about dogs here.
Much better. Come on.
Yeah.
So, var
Okay.
system
So
equals.
let's get our system prompt in there. System prompt just like puts some gravity on this LLM call in a specific direction, gives it some personality. So
You are an AI-powered assistant to help people adopt a dog from the adoption agency named Pooch Palace, with locations in Antwerp, Seoul, Tokyo, Singapore, Paris, Mumbai, New Delhi, Barcelona, ¿Dónde estamos? And San Francisco, okay? And London. Information about the dogs available will be presented below. If there's no information, return a polite response suggesting we don't have any dogs. By the way, the AI doesn't care if you misspell.
Yeah.
If somebody asks you about animals and there's no information in the context, then feel free to source the answer from other places. And if somebody asks for time to pick up the dog, don't ask other questions. Simply provide a time by consulting the tools you have available, okay? Keep all that in your head. There's going to be a test. All right, so I think we're good. Now let's try again.
So yeah, let's check it out. See what. All right.
Wow, there you go.
So it's better. So it's like now like knows that we're talking about Pooch Palace. We've given it this mission that the agent can now try to help us achieve.
Right.
So the next thing that we want to do is provide an integration into this application. And one of the ways that we can do integrations with our AIs is through something called agent skills, or just skills. And skills are kind of like a wiki for the AI that allows us to progressively load in knowledge into our AI. And it also allows, if you use skills in the way that we're going to use them, it allows this like progressive discovery of the actual knowledge. And so we have a library that we're going to use, which is the Spring AI Agent Utils library. It has support built into it for skills. And then there's a project called Skills Jars that allow us a way to package up skills, put them into our Maven repository, Maven Central, or your Artifactory Nexus, whatever, and then we can then consume those skills as dependencies.
So a skill is basically a folder with a skill.md file, and that text is weighted more heavy, it's weighted heavier than the knowledge that the AI model has. So if you tell it, hey, you're an AI model, you probably know just about everything on the internet, but you got something wrong, I've got a skill file here. If somebody asks a question that can be answered by both what's in the skill versus what you already know, prefer what's in the skill. It has a precedence over the knowledge that they would give you otherwise. So you went to skills jars. Well, you created skillsjars.com.
I did.
Thank you for that.
Yep. You're welcome.
Then you went there and published a skill that we wrote for Pooch Palace.
That's right.
As a jar in Maven Central. And now we have that jar here, Pooch Palace. And this is nice because you can version and audit and supply chain manage the skills that you use in your application in the normal way. Yep. We have that here. And if you go to GitHub, it's github.com, James Ward, right? Pooch Palace, and there's this skill. Whoops,
I forget what it was. So, there it is.
Skills.
Yep. And let's go look at our, I don't know, do you want to look at our cat skill?
Yeah, we got.
So as Pooch Palace, we have some unique things about the pets that we have available for adoption. And so we wanted to encode that knowledge into a skill so that we can augment the AI with, our very particular Pooch Palace knowledge.
Facts. Okay?
Yeah, absolutely.
For example, most people don't know that cat whiskers are actually high gain antennae, right?
True.
They're natural Wi-Fi extenders.
Yep.
Okay?
Absolutely.
This is a fact.
Yep.
So we're gonna use these facts in answering questions about the animals. So now let's set up the skill here, the skill integration, via a tool. What's a tool?
Yeah, so in order to provide this integration, really the AI has two ways that we can provide things to it. One way is through tool calling. Tool calling is the ability for us to tell the LLM that I have some tools available, and if you decide, LLM, that you want to use these tools, just let me know, and I'll invoke the tool on my side, on the agent side, and then tell you what the response was. And so this is really the primary toolbox for doing integrations with LLMs. So it turns out that the Spring Agent Utils library that has this skills tool in it that allows us to tell the LLM, hey, I've got these skills available. So in our case, we've got a dog skill, we've got a cat skill for Pooch Palace. And so then we indicate to the LLM, hey, I've got these skills available that you can use if you want to. Then if the LLM decides that it needs some additional knowledge, it can tell us, the agent side on Spring AI, to invoke that skills tool, go get the full file, and then give that to the LLM. And so all that gets integrated with what Josh just wrote there, right? And now,
well, let me walk through this here.
Yes.
I've created a skill tool. This is a way to teach the AI, the Spring AI framework to, it's a way to add tools to the tool belt of the model via Spring AI. And in order to make this work, there's a particularity for now that I think will probably get better in 2.0, where we also had to set up a tool called Advisor.
Yep.
An advisor is
this is like an interceptor for our actual calls to the LLM. So it allows us to intercept calls that are going to the LLM and the responses that come back. And the advisors just become in Spring the standard way to build many different paradigms. So we build RAG on top of this. We build MCP, tool calling, our skill stuff all on top of this.
What was the question?
Should I adopt a dog or a cat? And so now with our skill, what we should be seeing there, if we don't get an internal server error.
Okay.
Oh, try it. I don't know. Try it again. Turn it off. Turn it back on again.
Oh, no.
What happened?
What is going on?
I don't know. This is the first time we've tried this. We're just, coming up with it
Is this
live.
Did I do anything wrong? Skills tool.
I don't think so.
And the tool called, let's just try removing the...
Oh, try to turn on history.
Oh, turn on the history.
Yeah.
Conversation history. What could go wrong? Don't answer that. we already know. Okay.
Okay, there we go.
Oh,
okay, so worked.
There we
you just
go.
have to have the history enabled.
So cats are natural Wi-Fi extenders. This makes them, I think, a plus. That's a +1 in that column.
So let's walk through what actually just happened there. We made a call to the LLM, and we sent the user prompt. We sent the system prompt, we sent the user prompt, and then we also sent the list of tools that are available to the LLM, which included the skills that are available. And then the LLM decided, hey, it looks like you're asking about dogs and cats. Let me have you go fetch the skill, the full markdown file in our case, that has all of the contents with Pooch Palace specific knowledge about dogs and cats. And so then we sent that back to the LLM, and all this happened in that one chat client call, this whole back and forth with the LLM multiple times. And then finally the LLM responded, given the knowledge of Pooch Palace, dogs, and cats, it then responded back to us. So that was the full cycle.
Good stuff, but the problem is now, this is a stateless API, so if I asked another question, it would forget the answer it just gave us, right? If I asked the same question again, it would be like, here you go, here's the answer, brand new, I've never seen you before. So we need to enrich it with memory, which we're going to do via the prompt chat memory advisor, another advisor here that we're going to use to persist things in the database here. And then this is going to take a rolling window of the latest and greatest things that you've said. It's going to be stored in the SQL database here, okay? And we're going to specify that by specifying a repository, JDBC repository.builder.data source, putting in the data source here, voila, and data source and .build. Okay.
So there's many different ways that we can provide memory to our LLM. As Josh said, the LLM is a stateless thing by default, and so if we want something to be known across calls to the LLM, we have to manage that. And this is one of the more challenging parts of architecting these AI agents is how do we provide memory to it. And so, of course, Spring AI has built-in support for memory, and we can do that in a variety of different ways. The way that we're using here is that windowed memory, and so this is just going to roll through with a maximum of 20 or something messages is the default, and it's going to store the memories into our database as well. So really a pluggable system that you can use in many different ways to provide memory to your application. There's now an auto memory thing that is part of the agent utils library as well, which will just automatically manage memory compaction and some of these other techniques for you.
That's in the Spring AI community as well. Well worth a check out. Okay, here we go. I'm going to reload all that. I've enabled the schema generation here. I'm telling it to initialize a schema in which it's going to store memory. So if I refresh this, you'll see Spring AI chat memory is there. Now, if everything goes to plan, before we do that, the next thing it's going to ask us is, how do I ascribe the request to a particular user? And the way you can pass in any arbitrary string, and you specify that string, and you can specify that here as a parameter, right? Now, obviously, you can imagine in a more realistic scenario, such as the one we're going to have later, you would have a principal, a Spring security principal. So let's do that later. So Spring user, et voila. And this font being this cartoonishly large is kind of fun. Okay.
They can read it, you can't. That's okay.
That's fair.
Yep.
It's fair. I'm not here to read, I'm here to write. Okay.
Okay, so we've got our memory integrated into our chat client, and so now it should remember the things that we talk about. So I don't know, what's the, oh yeah, you got to put in your ID. Let's do a quick little test on this. So great, it knows who you are, and then if you ask it another question, that persistent should kick in, and that advisor should be able to pull the memories out of the system, send those along in the next request. So did it work?
Yep, it did.
Awesome.
Next, we need to give it access to the dogs, so we'll support RAG.
Yeah, so for RAG is our next technique that we're going to use to build our AI agent that's going to be able to be connected to external data. And so in this case, our external data is our database of dogs, and we need to have a way to provide dogs that the user may ask about into the LLM. And so RAG is this approach where what we do is we take our database of dogs, we then create vector forms, vector representations from a LLM, usually an embedding model. We create these vectors that represent each of our dogs. We store those, in our case, in PG vector. And then when the user asks a question about a particular dog, we're going to do a similarity search on their prompt that they've put in with our list of dogs that are available. And what then happens is if we match on a dog, then we're going to take that record and put it into the prompt that's going to go to the LLM. And so that's the whole RAG approach. We're going to kind of cheat here, and instead of like setting up our ETL pipeline that has create and update procedures to create our embeddings on create and update, we're going to manually create our embeddings.
Right. So I'm doing that when I start up the program. When I inject the repository, I go through each record in the database. I'm going to create a Spring AI document with text. It's arbitrary. As long as you're consistent from one run to another, it doesn't matter. Normally, you'd take a large enough body of text and you'd tokenize it. You'd split it and pass in the collection of documents from that process into the vector store, and they'd be correlated, 1 of 5 or whatever. But here, I've just got 1. It's small enough to fit into a single document. Oh, wait, this is a document about dogs, so of course we shall call it a document. There you go.
Of course.
So we want to tell the AI model to know to consult that vector store when it loads up. So we'll create another advisor here.
So the vector store is just our general API in Spring AI that we can use to talk to any vector store representation. And so this is, in our case, going to be that PG vector, but many options that are available as vector store implementations in Spring AI.
And it's going to take time when it starts up, this very first time. One of the reasons I love Bedrock's
the
embeddings is so fast, okay? That's 5 seconds with all the embeddings. If you try it with a distinguished competition, it'll take 2 or 3 times longer. Don't ask me why.
So, and again, we're doing this on startup, creating those embeddings because we already had our database of dogs. In your case, you're going to do this on create or update. When you get new records or updated records coming into your system, you're going to create those embeddings. But you do need to have the embeddings because that is a vector that then we're going to use to do a similarity search with what the user has prompted.
We found our buddy Prancer, but it's a giant paragraph of text, and I can't really use that text to pass it to other layers of the API. So what I want to do is I want to get something strongly typed. This is Java. We have an amazing opportunity by using a nice, strongly typed language like Java. And we don't have to specify schema for this either, and like we do in other untyped languages. So we're just going to write a nice little Java object here, a little class. Okay, we'll say record, dog, adoption, suggestion, int ID, string name. I'm going to take that type there. And instead of asking for the content back as a string, I'll say entity, voila, and I'll return this. And ironically, I'm going to return a strongly typed object only to then pass it back from Spring MVC, which will turn it back into a string again to send back over the client. But the point is, I have access to that data as a strongly typed integer, right? Yep. There it is, int 45, and I can use that for correlation and so on.
In this case, different ways that this is done yeah, we do want the string here. So there's different ways that this is done. Some models support what's called native structured outputs, in which case we're going to the LLM actually is going to be sure to return us the right JSON. We usually provide a schema that we want that to conform to because we have the types and we have Jackson in Spring. All that schema information just gets passed automatically. In this case, we didn't turn on the native structured outputs, but we could.
Right. So now the next natural thing, any red-blooded human being at this point would want to adopt Prancer. I think we found the dog of our dreams or nightmares. So let's support that process by giving our model agency, the ability to talk to the world. We've already seen other people's tools being used, this Spring AI skills tool and things like that. We can write our own, trivially.
Yeah. So there's different approaches for how we do these integrations with just our own tools or potentially third-party tools, where we can do tools in the same process as our AI agent, our AI application, and that's just using this @tool annotation. We need that description. That's very important.
That's your schema.
Yeah, so that description is what is really going to indicate to the LLM, here's when you should call this tool. So remember how tools work, is we provide all the tools that are available to the LLM, and then it decides when it wants us to call a tool, we call the tool on our side. And so, great, we've got our adoption tool. We'll get into MCP, which is the other option for tools in a minute. So great, so we've got our tool. Now we should be able to adopt this dog, right?
Yeah.
Do we still have our memory? Is it going to send our memory along? Let's see.
Barcelona, Puig Palace location.
So if everything goes correct, then that should be 3 days from now.
Yeah, today is the 15th.
Yay.
Oh,
okay.
it's tax day, I just realized.
Oh
boy.
Pay your taxes.
Okay, in the States, not here. I'm sure it's fine. Don't freak out. Okay, so that,
So we got our tool calling.
did we know that worked? I didn't actually put a breakpoint or anything. Oh, that's so sad. Here, var I.
Oh, you didn't print something. Yeah.
Sad.
I mean,
Scheduling.
if it hallucinated that would be
Ironic,
impressive, but-
amazing. Okay, dog ID for. Okay.
Oh, I wish you had string interpolation there, buddy.
Seriously, and the also operator. Okay, 5. Wait, it might consult its memory, by the way. These things are really smart. Great, April 18th, scheduling 45. Okay, great. Now, what if somebody else wants to repurpose this business logic, right?
Yeah, so the other option that we have for tools is we can use MCP servers. MCP is a great way to provide these types of integrations. You've probably used MCP with your AI coding assistant. Where I think MCP actually has a lot more value is in these enterprise integrations, because it's kind of like microservices for our AI agents. And so what we can do is we can take this tool call, move it out into an external server. We can also use MCP servers from third-party providers, and then we can wire our agent with these remote MCP servers. So Josh has now created a new MCP server. Anything special we need to do?
Refactor
Just tell it.
to.
Yeah.
Yep.
So we're going to change the annotations here from @tool to MCP tool. We could reuse actually the @tool annotations, but then we need to do one additional step to set things up. So we'll just change it to the MCP tool. And now we need to change it out so our agent is going to talk to that MCP server instead of talking to that local tool. So to do that, we need to, did you set the URL already in the config?
Yes, sir.
Okay, great. And then we're going to be able to tell our chat client to, hey, here's this MCP server that you have available to you. What actually happens underneath the covers is when our Spring AI application initializes, it's going to go out to our MCP servers. It's going to get the list of tools that are available on that server, and then populate those tools into the context, into the LLM call that then we're going to make so that then it knows about the tools that are available. There is another approach that we can do for really kind of a more efficiency side of things where, let's say we've got a lot of tools. We've got hundreds of tools, and there's some challenges with having so many tools. Is that one, it gets harder for the LLM to decide when to use a particular tool. And then also, there's quite a bit of metadata that it describes the tools. There's the descriptions, but then there's also the input and optionally the output schemas. And so what we need to do is, oftentimes when we get a large number of tools, is have a way to reduce that metadata information, because that metadata gets sent on every LLM call. So we can do a tool called the tool search tool, which provides semantic search using embeddings or Lucene to be able to first allow the LLM to search for tools, and then we provide in the subsequent call the actual tools.
So
did it all work?
That worked. We have a distributed system, but as soon as we did that, we have created a hack, right? We have a distributed system. That's another port that people can knock on. We need to secure this thing quick. Stat.
Lock it down.
Right? So back to security. We're going to set up OAuth. Who loves OAuth? Don't all raise your hand at once. I love OAuth too, actually. But it is, what does it do?
So we need a standard way to be able to authenticate to our MCP server. We didn't show the auth step for our book MCP at the beginning, but there is actually an auth server, and that auth server requires that the user, in order to invoke that MCP server, is authenticated. And so we can do the same thing with our Pooch Palace scheduling service, and we can actually propagate user identity through from the agent call to the MCP server. So that means we can authenticate both on the front door for the agent, but then also know their user identity when we invoke that MCP call. So what do we need to set up for that?
I'm going to create an authorization server. You can use any valid OAuth IDP so long as it supports dynamic client registration. In this case, I'm not even doing dynamic client registration since it's a rather homogeneous setup here. I've got a client and a service that know about each other in the same organization. They can afford to share and work with and trust the same tokens, right?
Yeah.
So they have a mutual source of truth. That's the Spring Auth server here. But it could be Okta, it could be Keycloak, it could be Active Directory, it could be anything that produces and validates and vends OAuth tokens, okay? And I've also configured, via some config here, a OAuth client. Now, you might do this in a self-service form or whatever, but I'm just going to do that. And I'm also going to set up the MCP security, okay? So we're going to say security filter chain.
So what we need to configure on this side is this token server that's going to be able to create tokens and validate tokens. It needs to have some knowledge of how MCP actually works. So there's a library in the Spring AI community that adds this knowledge, this capability into the auth server so that it will be able to authorize MCP calls. So we have to set up the security chain there, and this is always a tricky one, huh? Is the MCP authorization server. And then we need to, allow...
OIDC.
OIDC, yep.
Okay, fun. All right, good. Easy. And then we set up, it's actually more, you know what the hardest boss in this level is? The font size.
It's throwing you off for sure.
There we go. So I locked down everything. I did form login. I set up I included an extra processor on the security filter chain coming from the Spring AI community MCP security project here. And I've said I want to set up an auth server with OIDC, but I'm going to lock it down for MCP interactions on the auth server. Finally, I'm going to source my users from the SQL database, which we have configured and running in the background there. Okay. Okay, here we are.
Great. So we'll have our users in our database. We've got our MCP auth set up. Anything else we need to do on the auth server side? Auth
server, I think, is all good. Now let's go back to the agent itself, and we have to restore the OAuth client connectivity, which I commented out earlier. So here we're going to say, as an OAuth client, the MCP client, when it tries to make a call, it's going to say, hey, do I have a token? If not, it'll redirect to the auth server and begin the OAuth dance to allow us to create a token. Or if it's already got one, it'll promulgate it when it sends a request in band, basically. So here's the connectivity on the client side saying, hey, go to the OAuth server and get the token. And then because of this, because we're no longer able to talk to the MCP server in a secure way, since we're no longer able to talk to it without a token, right? We need to tell it to defer the initialization of what it has until we actually make the call with the token in band. So that's what that property is.
There is another alternative that we could go with here, which is you can say, all right, allow users to get the list of tools unauthenticated and then only require auth on the actual tool call. That's another option, but in this case, we're just going with the easy one, which is deny access to even listing tools until the user is authenticated.
I'm bringing back security.
Bring back security.
Love the security, love it.
What do you think the chances are this works?
I mean, pretty great. I did it in like 5 minutes yesterday. It'll be fine. What could go wrong? It's security. It's OAuth.
It gets a little tricky, but
says nobody ever.
I believe in you.
Okay, thanks, buddy.
Okay.
And then finally here, we have to configure the customizer in the client, right? That's also important.
Oh, yeah. So the way that we need to actually have like an interceptor that's going to intercept the calls to the MCP server and add the token from our web application side so that then those tokens get passed to the MCP server call as well. So we need to add that interceptor with our HTTP security customizer. And yeah, we're going to just configure that. Again, this comes from the Spring AI community library from our buddy Daniel, right?
Daniel Gagne,
amazing
who's
work
here,
on that.
And he's got be careful, he's got a clipped wing this time. Okay, so we've got everything except for this. We have to specify the issuer, and we did that actually. So this should be fine too. Let's go ahead and, I got the security, reload.
Oh, there's just a lot of risk here, bud.
Okay, I'm rooting for us. Ready? 127.0.0.0. Oh, we have to, just to make life a little easier, one last thing here. Gonna, instead of URI encoding the query in a browser, I'm gonna just reify the question here. So
we need to use, Josh was using his curl-like thing before, and that's great. But now that we're doing OAuth, it's a little challenging to do OAuth through curl. So we're going to use a web browser, and we are just going to hard code our question in here so that makes it easier. We don't have to URL encode that thing manually. So, yep, when can I pick up Prancer? Oh, and then did you do your principal?
I'll do that on the server side. Yeah, good. Okay. Great. Question. Get rid of the history so that it doesn't cheat and look at its own notes.
Oh, yeah. Can't cheat with memory there.
And then on the server side, we want to take advantage of the fact that we now have access to the current authenticated user. So security context holder dot get context dot get authentication dot get name rolls right off the tongue. Okay, easy. And then it's this user right here, right? Hello.
There we go. Okay.
Take 5.
Let's see if it works.
Ooh, got it. Okay. I went to /ask. It redirected me to the auth server. So far, okay.
So now it should be calling back.
18 April.
So, okay, we got a response, and now it knows. So our MCP call then propagated that user identity through, and security worked. First shot.
First shot, no problem. There's no doubt.
Nice work,
Never any
Josh.
doubt. And we have, this whole time, also been sending data to Grafana, which is nice. So, oops, what? Here we go. Okay, drill down, metrics. Look at that. And so very important, we got observability. This is important as well when you build production. This is the difference between AI and production-worthy AI, is you want to have observability. You want to know how much you're spending on tokens and how long operations are taking and so on. Here's your token usage. You want to know if you're bankrupt or not, right? This is important. Keep track of this stuff. Keep an eye on the single pane of glass. So we have secure.
And you didn't have to do anything to add the observability.
No, just added the open telemetry starter and pointed it to the right thing. We have now. What do we got?
Let's see. Systems? Yep, so we got our AI application. We've got skills. We've got RAG. We've got system prompts. We've got MCP tool calling. We've got observability. We've got security. Whew.
Yeah.
Did we get it all?
Yeah. Production-worthy AI. This is where things matter. I talked about this yesterday in the keynote. MIT did a thing last year. 95% of AI solutions fail, and it's because they don't integrate in the context of the organizations in which they live. You and I and all of us here, we are the guardians of the business logic that runs the enterprise in Java and in Spring. We have an amazing opportunity here, right? We can build secure, production-worthy systems that integrate well, deeply into the organization.
Yeah.
There's never been a better time to be a Java and Spring developer, everybody. Thank you so much.
Thank you, buddy. Thanks for coming.
I have a question. Who learned something new? Something new? Anybody? Fantastic. Who had fun besides us? Oh, very good. Thank you, everybody. Go see his talk if you want a deep dive on MCP. When's your talk?
Yeah. Oh, yeah, 11:30.
11:30. That's today, not like next Tuesday. That's today in this conference. Deep dive on MCP from just a roving tour of all things MCP. Thank you. And check out the Spring AI community. We've only begun to scratch that surface.
Thanks, buddy.